Hello, dear students. I hope you are doing well. Let us start and see together the first lecture, which is an overview on the course entitled Databases within Artificial Intelligence. The outline of this course is as follows. We start by an introduction and then see some databases fundamentals. Thereafter, we are going to see how to model databases with some principles. What are relational databases? What about databases querying? And discuss some approaches related to how to integrate AI techniques within databases. And we finish this lecture with a conclusion. Databases are a structured collection of data. They are fundamental for storing, retrieving, and managing large volumes of data. They serve as central repository for storing and managing large volumes of information in a systematic and organized manner. Used in almost all modern settings involving data managing as business research and administration. It's important to understand how databases work and interact with other applications. Databases are critical for training and deploying AI models. They play a crucial role in AI applications by providing the foundation for data storage, retrieval, and management. Let us see together the first chapter of this lecture, entitled Databases Fundamental. The goal of the first part of this chapter is to distinguish between information and data, where information is the result of processing raw data to reveal meaning, and it's the key to good decision making for organizational survival, while data must be formatted for storage, processing, and presentation, and are the foundation of information, which is the bedrock of knowledge. In order to understand well this part, we will work over first tutorial and lab sheets that will give you an overview of an Excel file to discuss its contents. Through these tutorial and lab sessions, you will be able to make well the difference between data, information, and even knowledge, and how to manage them by using or not a database. We move now to the part dedicated to the databases management system, which is a collection of programs that manages, structures, and controls access to data, such as Oracle. Its roles and advantages are as follows. DBMS is intermediary between the user and the database. The database structure is stored as a file collection. Files can be accessed only through the DBMS. And finally, the DBMS enables data to be shared and integrates many users' views of the data. We move now to the second chapter, where we are going to see the main principles of databases modeling. In this chapter, we focus on the entity relationships model, which represents a conceptual database as viewed by end users, and it's composed mainly by entities, attributes, relationships, and cardinals. Concerning the entities, they refer to a set and not single occurrence, and a table and not a row in a relational environment. They are described by a set of attributes, such as one of them is the ID. For example, the entity student is described by student name, first name, email, phone, etc., where we should put an ID such as student ID. Here we are going to see two models which are two different representations, the chain model and the crowfoot models. So for the chain model here we have, for example, the attributes which are put in ovals, and student entity in the cross-foot model is represented by a rectangle where the attributes are put in. Relationships are very important in the ER model, which are associations between entities. Two main features should be considered: connectivity and cardinality. Connectivity describes a relationship classification, while the cardinality expresses minimum and maximum number of entity occurrences associated with one occurrence of related entity, established by very concise statements known as business rules. Here, for example, we have two entities, professor and class. For example, the professor can teach many classes, while a class can be taught by one and only one professor. In order to develop an ER model, it's important to follow those main instructions. The database design is an iterative process. It's important to create a detailed narrative of the operations of the organization, identify the business rules based on description of those operations, identify main entities and relationships from business rules, develop an initial ER model, identify the attributes and the IDs that adequately describe entities, revise and review the ER model. We move now to the chapter 3, entitled Relational Databases. In this chapter, we are going to focus on the relational model. In fact, relational databases are based on relational model, which is a logical view on data rather than physically produced. The relational model is easier to understand than other types of modes, such as the old ones, like hierarchical and network models. The entities and their relationships in this model are transformed into tables defined by attributes and keys. For more details, feel free to pause the video. Here is an explanatory example. In chapter 4, we are going to discuss the process of querying databases. To this end, the DBMS processes SQL queries in 3 phases. The first one is parsing, where the DBMS passes a query and chooses the most efficient access and execution plan. In the execution phase, the DBMS executes the query using chosen execution plan. At the end, in the fetching phase, the DBMS fetches data and sends the result back to the client. SQL commands and functions are used for data administration and manipulation, and to query a database for extracting useful information. Here, for example, we have a query for table definition and another one for database querying. In chapter 5, we are going to see some approaches that can be used to integrate AI techniques in databases, such as machine learning, natural language processing, business intelligence, as well as data mining. At the end of the chapter, I'm going to ask students to realize and implement an application in the form of projects that can integrate AI with a database in the context of an organization. This would be my final statement. This course aims to gain a solid understanding of databases and their importance in AI, enhance your ability to design and manage databases for AI applications, develop practical SQL skills for data retrieval and manipulation, explore techniques to seamlessly integrate AI algorithms with database systems. Thanks for watching. Goodbye.